Okay, so in the second part, we're going to do algebraic expressions that have a binomial or a trinomial or something like that on the bottom, which will cause us to do our polynomial factoring. So we're going to prime factor this by doing polynomial factoring as well as GCF kind of factoring. So let's factor these as full as possible. So the first thing I did was took out the GCF of each one and factored that out, but then we can go further on these and do another factoring with the unfoiling trial and error type factoring. So let's do that next. And just to show you it similarly to the way I did 1 through 3, we're going to write the prime factorization of the first denominator and the prime factorization of the second denominator, which we will want to split these x's. You want to write them on top of one another like that so we can do our circling trick. So first you find any they have in common. We have an x plus 1 factor in common. We have an x factor in common. And then any that they don't have in common, you have to circle those single leftovers. And you'll need one chunk from each circle. So you'll need a 2 and a 3 and an x. Those are all the singles. Then you'll need one x from the pair. And you'll need one x plus 1 from that pair. And then you'll also need another x plus 1 from the single, from this one. And then you'll need another x plus 4 from that single. And then we'll put it all together on the next page, and this will be the LCD. So here we have the equation written again, and remember this is its factored form, and this is what we're shooting for. So we have to figure out what factors are missing from each denominator and multiply those on top and bottom. So we have 2x already, but we don't have the 3 and the other x, and we don't have the x plus 4. So those are all the things that need to be tacked on to what we already have to make our new denominator, which I have simplified down here. So whatever I'm adding in purple here, I need to multiply that same thing on the top. So I need to multiply this by 3x, x plus 4. So whatever the missing factors are get multiplied on top and bottom. Then same thing on this other one. We've got a 3 and an x, so all we need is the 2. And we have one of the x plus 1s, but we don't have the other x plus 1, so we need to multiply him in. And then we already have the x plus 4, so we're good. So the only thing that this one needs to be multiplied by is a 2 and an x plus 1. So we need to multiply the top and simplify as much as possible, so I'll do that on the next step. So first I just rearranged the numerators a little bit. I multiplied the x times the x and put the 3 in the front. So I got this numerator, and then I took this 2 and basically stuck him in front there and wrote the other two factors side by side. So we're going to have to do a little more work before we can add these, because in order to add them, they're going to need to have some like terms and be able to smush this together a little bit. So I'm going to make one big fraction with the denominator here one time instead of 2 now. And it'll take a couple of steps of simplification. So first I'm going to distribute this. Then I'm going to put a plus here. Be careful if this is ever minus, because you'll have to distribute that minus to all the things after it. But for now it's just plus. And then I'm going to need to FOIL this, so let me do that off to the side. And then I'll multiply everything by 2. And so what we have here is 4x squared plus 6x plus 2. And so now we can look across the top and see if there's any like terms. And again, like I said before, if this was a minus, we would have to change the signs of all the things after it, and they would all become minuses in this case. But it's plus, so we can just go through and find like terms and add them together. So we want to add like terms. We can add these two terms is all I can see up there. So we do 3x to the third plus 16x squared plus 6x plus 2 all over 6x squared, x plus 1 squared, x plus 4. And honestly, just like we did in the section where we had to simplify these, we would try to factor the top and factor the bottom and see if any factors cancel. But I don't believe there is going to be any factoring that can be done to the top, so we are going to stop there. Okay, so in this problem we want to start the problem by factoring. If we start with this one, we get xx 1, 2, minus, minus would be the proper factoring of that one. And then you'll notice that this factor and this factor are almost the same, and it would be nice if they were the same because then we'd have less things in our common denominator. And so what we're going to do is, we talked about this before, you can switch the 1 minus x to x minus 1 as long as you factor out a negative 1. So we can switch the order of a subtraction as long as we factor out a negative 1. And we don't really want that negative 1 in the denominator if possible, so you're allowed to just move it to the top, because a negative on top or a negative on bottom still makes a negative fraction, and so it doesn't hurt anything to move it to the top. So we're going to see what denominators we have now. Okay, so I've moved that negative 1 to the top and made that a negative x. Then another thing I do is whenever this is a subtraction, what I want to do is change the signs of the whole numerator that follows the subtraction. So in other words, we're going to add op this, which is add the opposite, and so we're going to change this to adding and then change the signs of everything in the numerator that follows. You only need to change the numerator, not the denominator. And so that way when I write it down here, I will write it as a negative 2x plus 1. Now we need to figure out what is missing in our denominator and what our common denominator needs to be. As you can see in our denominators, we have one match and we have one that doesn't match, so we need one of each. So our common denominator is x minus 1, x minus 2, one of each from each circle. And so this one is already complete, so he doesn't need anything on bottom, which means he doesn't need anything on top, whereas this other one is going to need an x minus 2, so since we had to write it on the bottom, we also have to write it on the top. So now we want to simplify this and simplify this so we can then add the two tops together. So when I distribute this, I get this part, and then this you can't really do anything with, so I just repeated it over here. And it turns out when we add like terms, and what we're left with is negative x squared plus 1 over our common denominator. But this can be simplified a little bit more, so we're going to go to the next page with that answer. And you may ask yourself, well, when do I know when to stop? Well, the basic rule of thumb is that you don't stop until you have factored the top, factored the bottom, and seen if any factors might cancel out. And so the top can actually be factored. It doesn't look like anything special now, but we never like to have a negative in the front, so let's do this. Let's take out a negative 1, and that causes this to be positive x squared minus 1. If you distribute this back, you'll see that it equals the same thing that we started with. Now, this looks like something special. That is a difference of squares pattern, so that's going to be able to be factored again, and so let's do that on the next step. So we have a negative 1, and then we have the difference of squares pattern is x minus 1 and x plus 1. And then we have an x minus 1, x minus 2 here. And if any factors are similar, we can divide them out, or we call that canceling sometimes. And so you end up with -1 times x plus 1 over x minus 2. And I would consider that a fine answer. You also will see a lot of books will just take this -1 and pull it down as a negative in front of the fraction. So you might see it written like this. And that would help you to be able to lose the parentheses because that negative applies to the whole fraction, and that would probably be the most simplest way to write it. But I would take either this or this as an acceptable answer. Another thing you could see a book do is distribute the -1 in, and so if they did that, it would be -x minus 1 over x minus 2, and that would be another possible answer. I feel like in this section we need to do just one more example just to make sure we've got this process down. And so on this particular example we need to factor the two denominators and see what we have in common and not in common to get the common denominator that we need. So this denominator factors like this and this denominator factors like this. It's the GCF type factoring. And you look at them on top of one another and we can see they have this in common and this not in common, but you need one of everything from each circle. So our LCD, you need a 2, you need an x, and you need one of the x minus 2's. And you can pretty easily see what's missing in each one. So this denominator needs a 2, and then it will look like the other one. And so we need to multiply the top by 2, and that will be distributing it through. And then the other one looks like it needs an x, and then that means the top is going to have to be multiplied by x as well. So let's multiply across the top. We'll distribute this, and also deal with this negative. So what I would do is make that a plus and stick it on the x so that it will distribute through with the x. So this gives you 2x plus 4, and this gives you -x squared minus 2x. So let's combine like terms, and it turns out that this and this cancel out, make a 0, and we end up with 4 minus x squared over 2x, x minus 2. Then we need to factor to see if anything reduces or cancels out, and we have a difference of squares on top, so that is a 2 minus x and a 2 plus x. And the 2 minus x and the x minus 2 almost cancel, except that they're backwards around the subtraction sign. So if we pull out a -1 or factor out a -1, we can rewrite that as x minus 2 and switch it, so that this will cancel with this, and that just replaced it, and so that looks like all the canceling that we can do. And so we basically have -1 on top with a 2 plus x, and you can also write that as x plus 2 because it's fine to just switch it around a plus sign. It's commutative, so you can write 2 plus x or x plus 2, it doesn't matter. And then 2x is all that's left on the bottom. And then again, they might distribute the -1, or they might pull the negative down into the front, but this is a potential answer left like that. So in other words, you could write -1 x plus 2, just switching the x and the 2 over the plus sign, over 2x, or you could write the negative down in front with an x plus 2 over 2x, or you could keep the x plus 2, 2 plus x. It really doesn't matter, but this is probably one of the most common ways a math book would leave the answer. This way is just fine, and even leaving the 2 plus x is fine as well.